Hi, this is Mr. Merrill. In this video, we're going to talk about proportionality. So we have a relationship, K equals half mv squared. K is kinetic energy, m is mass, v is velocity. It asks, first of all, how would the velocity have to change to double the kinetic energy? So using the method I showed you in class, we can imagine a 2 in front of the kinetic energy, and an x in front of the velocity. And the question is, what would that x have to be for things to cancel us out to send us back to this original equation? So think about it for a moment. But you can see if x is the square root of 2, inserting that in there, we can see that when we actually go and apply this square, this is now square root of 2 squared is 2, v squared. And we see that we're back where we started, so that was a correct choice. So how do we explain that? We say velocity increased by a factor of square root of 2. Okay, we can erase that and move on to the second question. It says if we now triple the velocity, so we can imagine putting a 3 in front of that velocity, an x in front of our kinetic energy. If we triple the velocity, how does the kinetic energy have to change? Well, we have this factor of 3 in here is going to get squared, so that's going to leave us with overall factor of 9 on this side. Meaning that this has to be a 9. Okay, so we would word that by saying K increased by a factor of 9. So those are two examples how to deal with these kind of proportionality questions when we're given an equation. We'll see next how we deal with these proportionality questions when we're given a graph. So it says a relationship is shown on the graph to the right. So first of all, we can first recognize this is a hyperbolic relationship or an inverse relationship. We have some variables here, so we could write an equation. We know that period is related to the inverse of frequency by some constant. We could call it m, we could call it k. I'll just go ahead and call it k. But we know there's some number here that relates frequency to period. So now we can answer the question, if we want to triple the frequency, by what factor does the period have to change? So we can imagine tripling the frequency. And wondering what that has to do to the t here. But think about it, we've introduced a 3 in the bottom of this side of the equation. So for things to balance out, we have to introduce a 1/3. On the left side. So those would cancel out, and we're back to where we started. So 1/3 was the correct choice. So period is now reduced by a factor of 1/3. So that's the answer to this first question. We're going to erase that and try to answer the second question. So if we were to half the frequency, so same setup, if we were to half the frequency, by what factor would the period have to change? Well, think about what you're doing to this right side. You're dividing by 1/2. If you were to rearrange this, 1 divided by 1/2 is the same as 2. So you realize that that x in front of t, or that factor in front of t, has to also be a 2. So period increases by a factor of 2. Okay, so that's how you get it from a graph. First of all, you have to set up something like this by looking at the graph. Remember, it's just going to be based on the shape of the graph, and the two variables are always going to be related by some constant. You can call that whatever you want. I call the constant usually either m or k. Okay, so if you have any questions, just email me.